Hello everyone, welcome to the class. Let's continue to talk about assembly. Today we will focus more on the functions, function call, function return. I will also show one very simple example, show you how to use assembly, how to write the assembly to do the swap functions, and how to call the swap function, how to do the swap, then how to how the swap function return the value. Okay, so let's get started to this topic. So far, this is something we talk in other videos. We have a stack. For the stack, we use a stack to do the function call, function return, to maintain the local variable, maintain the arguments. We maintain a lot of informations in each stack frame. Okay, so for the stack frame with two pointers, one is called EBP, the best pointers. Another one is ESP, stack pointer. We use these two registers to remember where's the top of the stack, where's the kind of bottom of this stack frame. And of course, as you know, ESP and EBP, they both are special purpose registers in this register table. And we also have a general purpose registers, a couple different registers here, EX, ECX, these registers to support your functions computation, to support each function, each computation, each instructions in your code. So which means they are shared they are shared by different friend, different stack friend, right? So here's the questions. If you have a different stack friend, different function to share the same registers, which means you might get your data override by the new functions. Like after you call new functions, the new function might override the data for your old function. So here's the example. We have a function called u, which call who, these two functions. So when we maintain this, we have a EPP, ESP maintained correctly because our systems, our CPU will automatically to do the push, to do the pop when we call the function, right? However, for other registers, they are not special. They are like a general purpose registers. So which means you might got some data override. Here's the example here. So in the U functions, we move this data 15213 into EDX. So we expect the EDX is a value we need. So EDX should be 15213. However, we do the code hood here before we add the value to the registers. So what it actually do is in hood value, it's also move another data, no, even though we don't know what the data is, into the EDX. So we get this EDX get override. This can be override to some value, which means the value we don't know what's this value here. This can be a number maybe 10, but you got the idea here. If it's got override, then after we return from hood to you, we work on this EDX. We will use this new value, not the old value, to do the calculation. So which means the data, the behavior, the program behavior will be wrong. If you want to do the manipulation for this value in the stack frame, but you don't pay enough attention on this part, so this data get override, and you still use this function, then it causes problem, right? So how to avoid this problem? How to avoid these potential issues? Especially you never know like what's your caller actually do or what's your callee. If I want to call library function, I don't know what's the library function's content, right? So how can I guarantee my data won't be updated by this like a callee function, this library function? So here's the solution. We kind of do some categorize. So far, we have 6 general purpose registers, right? We just, for each part of your caller or callee, each part of LAN should be responsible for saving a data of particular registers before the function call. or before the function return, which means if I'm the caller I want to call who this function, I have to save my data first. I have to put all the data in the registers to the memory, then I call another function. In this case, if after the function return, I can get the data back from the memory, right? So the idea of this is, okay, I have a function called u. So before I call who this function, I actually save data to memory. Then call who. So in this case, you don't need to worry about registers. And when the who function go to return, it's actually trying to do is it's actually just return it. But after return it, your u can get the data from here, from the memory. So after you got the who return the function, your u can call something to get some memory back from the data memory to you, back to you. So this is kind of the idea, how to maintain these registers value, how to guarantee the registers still have the same value you want to use to compute the result. So this is kind of idea. Okay, so if you understand this idea, we separate this idea to two different categories. One part of registers, you have to ask your u function to store. Some part of register, you ask your callee function, in this case, who to store. So for the first case, just as I said, for the first case, I have a caller and I have a callee. Before I call this function, I actually save registers. What registers we will talk about later. Then call. When your callee actually try to return, what it actually do is get callee registers back. Then return. So this is kind of the idea what they actually do. So your caller, before it's call another function, it save some registers, then call the function. Okay, and inside the callee function, it's try to save the callee registers to support this. And after it's returned, then your caller in this here, it will load the registers data back. This is ideal. So there's a two set of different registers. Some set before callee registers, some set between the caller registers. So for some registers, your caller function need to save this data before it's call another function. For some registers, your callee function need to save the data before anything inside the callee function. It's just save the data first, then go to do any computation or something. And before it's returned, it need to get the data back to the registers, then return to the function. And return to the caller function, caller also need to do the data back, load the data back from the caller registers. So what's a caller registers? What are callee registers? Actually, this is a group. We have three registers belong to the caller set registers. So before the caller function call another callee function, the caller need to save it. Save before call. Okay. Then another three inside this function, callee save function is save after call before anything in callee function. So before the callee function do anything, you need to save it back. In other ways, the callee function, callee save temporary list functions, need to get the data back, get data back before return. And for the caller functions, get data back after callee return. So after your callee function return, you can load this data back. So this is the difference between the caller function registers, caller safe registers, and callee safe registers. Okay, so inside the caller safe registers, there's a one particular one we usually use EAX to store the return value. So sometimes we call a function, we expect some return value, return output from the callee functions, right? We usually save it on EAX, which means if your caller function do not save these registers before call another function, EAX will get override. And EAX is the return value, and your original EAX will disappear. So definitely you need to do something before you call another function. So we save EAX value to a memory. Then we got the EAX from your callee function, and this is the return value. You can do anything about it. Then you load the data back. So this is about the EAX. So again, in summary, we have two sets of the registers. Actually, we have two categories. Special one, ASP and EBP. They are managed by your some operations. But there's some general purpose one, which in this case we have 6 different general purpose one. We try to split to different category. One is safe, caller safe registers. One is callee safe registers. And inside caller safe registers, there's an EAX. We usually use this EAX to store the return value from the callee function. So this is definitely a very important to save these caller function registers, caller safe registers before you call a function. Okay. Okay, so let's take a look of examples. This example is swap example. Inside the swap example is very simple program, just very basic program. We have a swap function called swap. Inside this call swap function, you just call swap. Then go to the next one. We have a callee function. So this is caller, this is callee. Okay, so and inside the callee function, you just do some swap and never return anything, but it's actually swap some like a pointer stuff. Okay, so based on this idea, what's what's your assembly looks like? So first part, we just take a look of this function, call swap function. So this is actually the assembly for the call swap function. Call swap function, what it want to do before it call another function? First of all, before this call swap, call another function because you have to kind of like create the stack frame for this function. The stack frame for this call swap function needs two data, just need two data. So what we actually do is first line, we do the ESP. So what's the ESP here? We create a space here and we move ESP to here. So right now, this is the new ESP. And how many byte? We move 8 byte. So now there's 8 byte here. Okay, so we have 8 byte here. Why we need 8 byte? We need to store the data. And what's the data? 2 integer data. Each integer data is 4 byte. So we need 8 bytes to store this data, okay? So then we go to a second line here. We move the first data into a place plus 4. What's a place plus 4 means? Means ESP plus 4, this number, we got ESP plus 4, which is here. We store the data in this place for the course 2. So actually we got the data course 2, 1A243, put into your stack here. This is for your memory. So inside here is a memory. We use the ESP, which is the address of your top. And we use this address to find the memory location, and we add 4 to this address. So we put the data into here. Then the third line, we move the course 1 to ESP. But where's the ESP? Here, right? So we got 15213. We put this number into this inside this memory. We put this data into this memory because we use ESP as an address to find the memory address of this location in your memory, and we put the data into the memory. Then we call the swap. So if you remember, when we call a swap, what we actually do? We do the push, right? We push a return address. So we got a return address here. We push a return address. Then, because we push, so we move the ESP to here, not this anymore. This is how we call another function. So this is the first step. Before you call another function, you have a couple preparation you need to do, which means you need to create a stack frame, try to load the data into the stack frame, and call another function. You also need to keep remember the return address. Then, now you are ready for another functions.
Yo, I have a questions. Why in the assembly we use positive numbers to compute the memory address, but on the stack it just goes down. It does not goes up, right?
This is very great questions. So let's take a look of here. Actually, even though we have a stack look like in this way, but remember, we use this in a reverse way. This is a memory address 0, and this is a memory address for, I don't know what's your memory look like, but you can have this. Actually, it's like the memory address should be decreased in this way. So when we say ESP plus 4, here's ESP plus 4, we actually goes up. We want to count goes up, right? Because the memory format is actually in a reverse way. This is the smallest memory address. This is the maximum memory address in this plot. So if you don't remember the details about this, check out another videos. We have this explanation on another videos about this part, okay? Okay, so now let's move on to check how we actually do the callee part, the swap functions. So this is the code for the callee functions. Actually, the swap take 2 arguments and do some like a value swap for these arguments. So in the assembly, we have a 3 stage of the assembly. The first one is set up. The last part is finish. And this is the body of the swap. So the body of swap is actually the code here. So everything else is just like before the body or after the body. So let's take a look of what's the body, what's the setup actually do here, okay? So remember, because we want to have a new stack frame, we call a new function. We want to have a new stack frame, right? So you can imagine that we want to create a new stack frame. How we actually support this new stack frame? First of all, we need to keep remember where's the old EBP. So right now the EBP, the old EBP is here, point to here. This is the old one. So let's say this is the old one. So we try to save the old one. So in the line here, we push the EBP. So actually we create the old EBP here. We store this old EBP and we move the ESP to the new place, which is here. Okay, so because we do a push, then we move ESP, we move EBP to the ESP place. So what is actually do? Old EBP point to here. A new EBP should put to here. So right now we update new EBP point to the same as ESP because this is a new best point of the stack frame. So this is a new button of your stack frame. So start from here, everything will be a new stack frame. So we want to create a new stack frame here. This is new stack frame for your EBP. Then what we actually do, we push EBX. So why we push EBX? EBX is a general purpose registers. Why we push EBX, not ESP, not EDX, not ECX. Remember, because EBX belong to the callee safe, right? So right now the swap function is a callee, it's not caller. So before the swap function, the caller should like try to store every information like EX, EDX, ECS. Callee function should store EBX, ESI, EDI. And here, why we only save the EBS? Let's take a look of the body, okay? Inside the body, which register we will use? We will use the EDX to store something. We will use ECX to store something. We use EBX to store something. We use EX to store something. So we use these four registers. In this case, do we use ESI and EDI? The answer is no, right? So actually, because we don't use this, we don't need to save any data. The only callee safe registers we use is EBX. This is why we use push to push the EBX into the stack. So in this case, you can see after we do push, what it actually do is put the EBX, the original EBX1, into this data, and we also move the ESP point to a new space. So right now, EBP point to the base. Let's make it clear. So right now, the EBP point to the bottom of the stack, and the ESP still point out to the top of the stack. Okay, so this is how you set up the data before you actually do. So in this case, the shipment should be very important here. Why? Because you have more data to do the stack, right? You have more data, you do the stack, and the stack affect the shipments of your the data you might want to get. In this case, you can see the stack is here. The two value, course 2 and course 1 is here. So if you want to access these two data, what you can do? EBP plus A, which is EBP here. This is EBP plus 4, EBP plus A. So EBP plus A give you a course 1. And EBP plus 12 give you course 2. So this is how you get the two data. And you save the first data, course A, from course 1 to EDX. Save the second data, course 2 to ECX. And in this table, we can see the course 1 has a data 15213. So we got 15213 into EDX. And the course 2 is 18243. So we got 18243 to ECX. So in this case, we load two data from the argument into these registers. Then we compute these register stuff. And how we compute? Actually, here, if you check this XP is actually the address. Why? Because this is a pointer. We use a pointer, the value of pointers is actual address. So we got the value inside the memory address. So this is memory. We use this EDX as memory address. This is memory address. We use this memory address to find the data in this memory address and put into EBX. So so EDX and ECX, they are edges. They are edges. And EBX, EX, they are data. So the value of course 1 and value of course 2, they are value. Okay, so the EX is a value of the course 2. Value of course 2. And EAX is course 1. So in this case, we got both value. And what we actually do, we put the EAX, which is the value of course 1, to this address. And what this address means? The address for the second one, right? So we put the value of course 1 to the address of the second course, the course 2. And we put the value of the course 2 to the address of your course 1. So this is how you actually do a swap. And this is very similar to what we have here. We have two memory address, SP and YP. We use different SP and YP, dereference it, get the value, and we store the value into the different memory address. So the same thing here happens here. Okay, so this is how the swap function actually do. And when you work on this swap function, I think the something you need to pay attention is the shipment. You need to know where's the data you want to get, because the stack got updated all the time. So you need to have a clear understanding which data you are talking about here. Is the data for course 1, is the data for course 2, or is this the data for return address? Okay. So after you finish everything, what you want to do is you want to get the EBX back. So right now, because EBX, you can see this is the course value 2. So we want to override it. We want to get rid of everything here. We want to get original EBX value back. So the old EBX value back. And we get rid of the stack here because we do a pop. So right now, the ESP point back to the old EBP. Then what we actually do is we pop. We also pop the EBP, so which means we want to restore the EBP. So we restore the EBP to our old EBP. So right now the EBP go back to point 2, back the old EBP, and we do the pop again. So when we do a pop again, remember the ESP will also get update back to the original one. So in this case, we finish and we return. So when we return, remember the return will get the return address here. So you got the return address as a next instructions. And what you will do is you will also update this ESP back to here. So this is the original stack frame for your caller functions. It's just getting back. So did you get the idea, whole idea here? When you do the function call, it's actually push something. Even though it's already automatically push something for you, you still need to maintain some part of the code by yourself, because the instruction they only support the ESP. You need to update the EBP. You need to kind of like move your EBP to ESP the position. You need to update the base frame base like pointers. You also need to check the callee safe registers, because some registers need to be handled in callee functions. Okay, and after you finish everything, you just try to get each data back. This is the idea. I hope you can understand now. Okay, so let's look at this example again to see how your assembly match to each action of your memory. First line, we got the EBP shifted by A, which is the first data, the address of first data, memory address of first data to store is into EDX. Then you get the address of the second data, store it to the ECX. Then for the EDX, you use the EDX data, the memory address, to find the data of this memory address, which is 1, 2, 3. You store it into the EDX. Then you got the second data by using the memory address of the second data, store the data into 456. Then because EAX right now is the first, EAX right now is actually the second data. You put the second data to the first memory address. So you update the memory address to from 1 to 3 to 456. Then the next one, you get the first data, store is to the memory address for second data. So which is 1, 2, 3. You override 4, 4, 5, 6, 2, and 1, 2, 3. This is how you actually do a swap in your memory by using the registers and using the memory. And how to use the memory here? Use the registers as a memory address, and you can access the memory. So I hope you enjoyed today's video. Today we talk about more details about the function call, function return. We also talk about some registers. They belong to the callee safe registers, and some registers they are caller safe registers. To manage these caller safe register or callee safe registers, you need to pay attention on your assembly body, which register you will need to use to support your algorithm. If you need to use it and it belongs to the, for example, callee safe registers, then the callee function need to save it. If it's belong to a caller safe registers, then caller function need to like register need to like store it before call another function. So this is some like details you might want to pay attention when you work on this assembly code. Okay, so again, I hope you enjoyed today's videos. See you next time. The assembly in functions is awesome.